So now we're going to look at polarization. So by now, we've kind of given everything we need to describe a longitudinal wave. We know it vibrates parallel to its direction of motion, and we've talked about how to describe its amplitude and its frequency and the wavelengths of these vibrations, from which we can find its speed. So we kind of have everything we need to describe a longitudinal wave, but we don't really have enough information now to describe our transverse waves. We haven't quite got enough of that yet. That's because we really just know that these only need to vibrate perpendicular to the direction of travel, but we have many options for how they could do this. We saw this with our electromagnetic wave, but actually we could think about this as just being one transverse wave, but actually it could vibrate by going up and down, like this. That red wave is a perfectly acceptable transverse wave that would meet all the criteria for. We could describe a transverse wave, and we could draw it just like this red one here. But equally, we could just as validly draw it like this blue one, where it's vibrating side to side. We haven't actually given any information on how it's vibrating. All we know it vibrates perpendicular to its direction of travel. But there are loads of ways it can vibrate perpendicular to its direction of travel. It can do it up and down like this, on this wave, but equally it could do it side to side like we were saying, or we could do it diagonally like that, or like that. Really, there's an infinite number of options for it to vibrate perpendicular to its direction of travel, and we haven't specified which one of those it's doing, if any, and the idea is it actually can switch between them. It can do a whole load of weird vibrations where it's perpendicular to its direction of travel. And so if we actually want to talk about what a wave's doing, we need to introduce this concept of polarization. And the key thing is that this exists only for transverse waves. So for transverse waves, we need this property called polarization, which describes kind of how they're vibrating. So the other thing we note is that we don't need this for longitudinal waves. I just want to stress this again, we will later, but because for a longitudinal wave, you know that it vibrates parallel to its direction of motion. You can't say anything more, you can't choose anything more about its vibrations. You know, if the wave is traveling in this direction, a longitudinal wave is also vibrating in that direction. It's only because a transverse wave vibrates perpendicular that it can vibrate however it wants, as long as it does that, which means it's got loads and loads of options. So, just pinning down this polarization thing, if all the vibrations of a transverse wave stay in one plane, we call the wave plane polarized. And that's like saying we're looking at this page and we've got this wave going on like this. What we're saying is its vibrations are perpendicular to the direction of travel, but inside this plane. So you can think about looking at, if this were a piece of paper, looking down, you can think of the wave vibrating up and down like this, in the plane of the page.
Hey guys! To continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.